Hello, my dear students. Let us take one more example. A figure shows the shear force diagram of a loaded beam. Find the loading on the beam and draw the bending moment diagram. Okay, this is the shear force diagram is given. So you have to calculate. You have to draw shear force diagram. How you can do? So start from this point at A. What is that? At A, we can see that shear force suddenly increases from 0 to 8. Means there is a support reaction at A of 8 kilonewton. Okay, here there is one support reaction of 8 kilonewton. So left side upward is positive. So you get this 8 kilonewton. Then between A and B, there is a straight horizontal line. Means there is no load between A and B. That is the meaning. Between A and B, there is a horizontal line. So there is no loading between A and B. Next, at B, you can see here, this difference is 5. Okay, till here it is 8. This is 5. So 8 minus 5, the difference is 3 here. This is 3 actually. Okay, shear force value here it is 3. So 8, what happens now? Shear force has a sudden decrease of 8 to 3. Okay, not 5. This is the difference 5. So here it is 8. 3, here it is 8. So there is a decrease of 8 minus 3 is equal to 5 kilonewton. Means there is 1 point load of 5 kilonewton at B. That is the meaning. So you have to put 1 point load of 5 kilonewton at B. Next, between B and C, you can see here there is an inclined straight line between B and C. Correct? Inclined straight line is there here. This is the inclined straight line, means UDL is there between B and C. That is the meaning. So, therefore, the beam is carrying a uniformly distributed load between B and C. You can see that there is a decrease of 3 minus 1. Means why it is 3 minus 1? See, full this is, still here, this is 6 kilonewton, right? Till here, this is 5 kilonewton. So, the difference is 1 kilonewton here. So, this is 3. Here this is 3 kilonewton and here this is 1 kilonewton. Okay, this is not 5 kilonewton. The total is 6. Till here it is 5. So the difference is 1. So there is a decrease of UDL value from 3 to minus 1. So how it is 3 to minus of minus 1 decrease, that becomes 4 and that is kilonewton. Okay, 4 kilonewton, but UDL is in intensity, so you have to divide it by the distance. So the distance between B and C is 2 meter. So this 4 divided by 2, that is equal to 2 kilonewton per meter. So UDL of 2 kilonewton per meter is acting between B and C. Next, at C, shear force has a sudden decrease of 5 kilonewton. See here, at C, here. This is 5 kilonewton. Shear force at this point is 5 kilonewton. So, what you can write? 6 minus 1 is equal to 5 kilonewton. Therefore, there is a point load of 5 kilonewton at C. Next, between C and D, there is a straight line. Between C and D, there is horizontal line, rectangle shape. There is no load. Means there is no loading is acting between C and D. That is the meaning. So, there is no load between C and D. Next, at D, here we can see that shear force suddenly decreases from minus 6 to 0. So there is a support reaction of 6 kilonewton at D. Here you can see here it is 6 to minus 6 to it becomes 0. So means there is a support reaction of 6 kilonewton at D. Now you can draw the loading diagram. How you can draw? That is this is the shear force diagram. So here this is 8 kilonewton, left side upward is positive, so this is 8 kilonewton. Between A and B there is no loading, then at B there is a decrease of 5 to 1, 5 to 3, so there is 8 to 3, decrease of 8 to 3, so 8 minus 3, that is equal to 5. Okay, then there is a UDL, because here you can see there is a inclined line, so UDL, that is here 3, here it is 3 and here it is minus, so 3 minus of minus 1, that is 4 divided by the distance, because this is a UDL, that is 2, so UDL of 2 kilonewton per meter. Then again at C it is is as to 6, so so here there is a point load of 5 kilonewton. How it is 5? 6 minus 1 is equal to 5 kilonewton. Then again between C to D there is no loading, but at D there is a this is 6 kilonewton, so right side upward is negative, so this is minus 6, so therefore you have to provide one support reaction at D. So this is the loading diagram. Okay, from this you can draw bending moment. That is very simple. At D, as usual method, at D it is 0, and at C, what is that? Force into perpendicular distance, and this is the direction is like this direction, so you can see that. Okay, so like this direction, so that is 6 into 3 is 18 kilonewton at C. Then at B, what is that? 6 into 5, this distance, and here this direction is like this. Okay, like this, that is plus 6 into 5 minus, this is like this, so minus 5 into 2 minus till be 2 into 2 into half of 1, that is again like this direction, so minus, so you get 16 kilonewton meter. Next at A, obviously it is equal to 0, but just check, 6 into full distance 7 minus 5 into this distance 4 minus 2 into 2 into half of 2, that is 1 plus 2 3 minus 5 into 2 equal to 0. Okay, so draw the diagram, bending moment diagram. This is shear force diagram and this is the loading diagram, then bending moment diagram. At D it is 0 and at C it is 8, here 18, at C it is 18 and at B it is 16, and then at A it is 0. Okay, at A it is 0. So here this is straight line and here this is parabolic curve because UDL, then this is a straight line. Okay, here you have to calculate where the maximum bending moment occurs, where the shear force changes its sign, there will be maximum bending moment, right? So it means shear force equal to 0 that point. So here where you can see the change in the sign, here you can see that is this is minus, this becomes plus. So at this point there will be change in the sign, so maximum bending moment will be here. Okay, at M. So that you have to calculate. What you have to do, first you calculate this distance here, this is still here. Okay, this is M. Okay, this, let us consider this full distance, that is equal to x from this D. Okay, now shear force at this point you have to calculate. Okay, here shear force at M. What is shear force at M? That is here till here we have to consider this side, minus 6, right side upward minus 6 plus 5, this minus plus this is UDL of 2 into, we want only this distance because we are considering shear force at this point M. So what is that? X minus 3. Full distance is X here to here. This is here, okay, not here. Till distance is here, so x minus 3, so equal to 0. So you get x is equal to 3.5 meter. Once if you get x, you can calculate what is maximum bending moment. What is that? 6 into x minus 5 into x minus 3, this distance, minus 2 into x minus 3, this distance, into x minus 3 divided by 2, that is equal to 18.25. The maximum bending moment is here. Like this you can show where is a maximum bending moment also. Here there is no point of counterflexure because there is no change in the bending moment. Okay, I hope all of you understood. Thank you.